Hello students, welcome to our live APS classes, and as all we know that this is our foundation course especially for the students from 9 to 12. And in our today's live lecture, we'll start next chapter, that is chapter number 2 for class 11, and the name of the chapter is Structure of Atom. And regarding this chapter, we discuss important 20 MCQ questions or objective questions from this chapter. So first of all, welcome to all the students who join with us our live APS classes. Now let us start with our first question from this chapter, and your first question is the increasing order, that is the lowest first for the values of E oblique M, that is charge or mass. For options are EP, NA, B, NP, EA, C, NP, AE, and D is NAPE. So you have to mention the increasing order, that is the lowest first for the values of E, M, that is the charge or the mass for the following options. So here, what is the right answer? So first of all, welcome to all the students who join with us our live APS classes. So the right option is NAPE. This is the right answer for the question number 1. And the explanation for this question is, so tell me the answer beta. EM, that is charge oblique mass. Charge oblique mass. First of all, you have to discuss for the neutron, that is 0 upon 1 is equal to 0. This is for the neutron. Second is for the alpha particle. That is 2 upon 4 is equal to 0.5. First one is for the neutron, second one is for the alpha particle, and third one is for the proton. This is for the neutron, second one is for the alpha particle, next is for the proton, and proton is equal to 1 upon 1 is equal to 1. And the last one is electron. Electron is 1 upon 1837 is equal to 1837. So this is the increasing order for the values of EM, that is the charge or the mass for N, alpha particle, proton, and electron. So this is the right answer. Next is your question number 2, the ionization enthalpy of the ionization enthalpy for hydrogen atom is 1.312 into 10 raised to power, not 10 raised to power, but 106 joule mole inverse. That is the ionization enthalpy of the hydrogen atom is 1.312 into 106 joule mole inverse. Then the energy required to excite the electron in the atom form, N is equal to 1 to N is equal to 2. So you have to mention the ionization enthalpy of the hydrogen atom is 1.312 into 106 joule mole inverse. Then the energy required to excite the electron in the atom from N is equal to 1 to N is equal to 2. Options are 8.51 into 105 joule mole inverse. Second one is 6.56 into 105 joule mole inverse. Third one is 7.56 into 105 joule mole inverse. And the last one is 9.84 into 105 joule mole inverse. So these are the 4 options. So the right answer is 9.84 into 105 joule mole inverse. So this is the ionization enthalpy, that is 9.84 into 105. So beta, energy required when an electron makes transition form. Energy required when an electron makes transition form. N is equal to 1 to n is equal to 2. Then E2 is equal to, तो हरिए बेटे जल्दी से इसका आंसर दें आप. E2 is equal to 1.312 into 106 into 1 square into 1 square and 2 square. That is n is equal to 1 and n is equal to 2. So E2 is equal to 1.312 into 106 into 1 square multiplied by 2 square. Hence the energy comes out to be minus 3.28 into 10 raised to power 5 joule mole inverse. Hence the calculation comes out to be minus 3.28 into 10 raised to power 5 joule mole inverse. And as all we know that delta E is equal to E2 minus E1. And E2 की वैल्यू आपको पता है 3.28 into 10 raised to power 5. और E1 की जो वैल्यू है that is to be minus 113.2 into 10 raised to power 6. 3.28 into 10 raised to power 5 minus 13.2 into 10 raised to power 6. Hence delta E comes out to be 9.84 into 105 joule mole inverse. So this is the right answer. Next is your question number 3, and your question number 3 is for a given principle level n is equal to 4, the energy of its subshells in the order. For a given principle level n is equal to 4, the energy of its subshells is in the order S less than P less than D less than F. S greater than P greater than D greater than F. S less than P less than F less than D. And the last one is F less than P less than D and less than S. So for a given principle level, that is n is equal to 4. Hence the order is of S less than P less than D less than F. This is the order, that is S less than P less than D less than F. Order of energy is all we know that S less than P less than D less than F. So this is energy level. This is 1, 2, 3, 4. 1, 2, 3, 4. 1 is equal to 1s, this is 2, this is 3, and this is 4. 2 is equal to 2s and 2p. 3 is equal to 3s, 3p and 3d. 3s, 3p and 3d. 3s, 3p, 3d. And last, that is for 4, that is 4s, 4p, 4d and 4f. So S less than P less than D less than F. So this is the sequence or the order. So this is the right answer. S less than P less than D less than F. Next is your question number 4, and your question number 4 is a gas absorbs a photon of 355 nanometer and emits at its wavelength or at two wavelength. If one of the emission is at 680 nanometer, the other is at. A gas absorbs a photon of 355 nanometer and emits at its two wavelength. If one of the emissions is at 680 nanometer, the other is. Options are 580 nanometer, 1035 nanometer, 325 nanometer, and 743 nanometer. So if a gas absorbs photon of 355 nanometer and emits the two wavelengths. So if one of the wavelength or one of the emission is at 680 nanometer, then the other is either 550 nanometer, 1035 nanometer, 325 nanometer, and 743 nanometer. So the other wavelength is 743 nanometer. 743 nanometer. So the other wavelength is of 743 nanometer. So from the law of conservation of mass, this is according to the law of conservation of mass, energy of absorbed photon must be equal to the energy of absorbed photon must be equal to combined energy of the two emitted photons. The two emitted photons, where ET is equal to E1 plus E2. So this is the equation 1, that is E2 is equal to E1, where E1 is the energy of the first emitted proton and E2 is the energy of the second emitted proton. Then energy E and lambda wavelength of the photon are related by the relation. Then energy of the photon and lambda, that is the wavelength of photon, are related to each other. Then E is equal to hc lambda. This is the equation 2. This is the equation 1, that is ET is equal to E1 plus E2, and the second equation is E minus hc oblique lambda. So this is the equation 2, where h is the Planck's constant. This is the Planck's constant, where h is the Planck's constant. H is the Planck's constant, where h is the Planck's constant. So here, and c is the velocity of light. H is the Planck's constant and c is the velocity of the light. So here the other wavelength is of 743 nanometer. So the value is substituting given values. अब ये जो given values हैं, these substituting given values in equation 3. इन values को हम क्या करेंगे, equation 3 में substitute करेंगे, और equation 3 आपकी क्या है, 1 upon lambda t. Second one is 1 upon lambda 1, and third one is 1 upon lambda 2. So these are the values. 1 upon lambda t is equal to 1 upon lambda 1 plus 1 upon lambda 2. This is the equation 3. 1 upon lambda t is equal to 1 upon lambda 1 plus 1 upon lambda 2. This is the equation 3. अब values put करेंगे आप, तो 1 upon lambda t की वैल्यू 1 upon 355, that is 1 upon 355. सेकंड की है 1 upon 680 नैनोमीटर थी, और थर्ड की जो है वो हमें पता नहीं है, सॉरी सेकंड की हमें वैल्यू पता नहीं है. 1 upon lambda t की वैल्यू क्या है, 1 upon 355 और लैम्डा 2 की जो है सॉरी लैम्डा 1 की जो है दैट इज 1/680 प्लस हमें 1/लैम्डा 2 की वैल्यू पता नहीं है। तो जब आप क्वेश्चन इसकी सॉर्ट आउट करेंगे किस तरह से करेंगे, 1/λ2 इज इक्वल टू 680 माइनस 355 oblique 355 मल्टीप्लाई बाय 680। लैम्डा 2 जो आ जाएगा दैट इज 742.77 नैनोमीटर, approximately 743 nanometer. So this is your question 4. Next is your question number 5, and your question number 5 is which of the following statements in relation to the hydrogen atom is correct? Which of the following statements in relation to the hydrogen atom is correct? Options are 3s orbital is lower in energy than 3p orbital. Next, 3p orbital is lower in energy than 3d orbital. 3s and 3p orbitals are of lower energy than 3d orbitals. And the last one is 3s, 3p and 3d orbitals will have the same energy. So which of the following statements in relations to the hydrogen atom is correct? So there are number of options. So here 3s, 3p and 3d orbitals have the same energy. 3s, 3p and 3d orbitals all have the same energy. All have the same energy. So this is the right answer. That is 3s, 3p and 3d orbitals all have the same energy shell. A hydrogen atom has 1s or first configuration. Hydrogen atom has first configuration and these its 3p and 3d orbitals will have the same energy. Okay. Hydrogen atom has 1s configuration and these 3s and 3p and 3d orbitals will have the same energy with respect to 1s orbital. So here this is the right answer. That is a hydrogen atom has 1s orbital and these 3p and 3d orbitals will have the same energy with respect to orbitals. So this is the right answer. Next is your question number 6, and your question number 6 is magnetic quantum number specifies. Options are size of orbitals. Magnetic quantum number specifies. Options are size of orbitals, B shape of orbitals, C orientation of orbitals, and D is nuclear stability. So out of these options, the magnetic quantum number specifies either the size of the orbitals, shape of the orbitals, orientation of the orbitals, and nuclear stability of the orbitals. तो बेटे जल्दी से आंसर दे इसका. So the magnetic quantum number specifies orientation of the orbitals. The magnetic quantum number specifies the orientation of the orbitals because the magnetic quantum number specifies the orientation of the orbitals This is the right answer for the question number 6. Now shift to the question number 7. The electronic configuration of silver atom in the ground state is. The electronic configuration of silver atom in the ground state is Kr 3d10 4s1, B Xe 4f14 5d10 6s1. One is Kr 3d10 4s1. Second one is Xe 4f14 5d10 and 6s1. C Kr 4d10 5s1. D Kr 4d9 5s2. So the electronic configuration of silver atom in the ground state is, which is the right answer for the question number 7. Yes, beta, which is the right answer for the question number 7. That is KR 4D10 5S1. So this is the right answer. So this is the electronic configuration of silver atom in the ground state, because the electronic configuration of silver in the ground state is 4D10 5S1, because the silver atom has the electronic configuration in the ground state is 4D10 5S1. So this is the right answer. Next is your question number 8, and your question number 8 is which of the following element has the least number of electrons? Which of the following element has the least number of electrons? Options are: which of the following element has least number of electrons in its M shell? M shell. So which of the following element has the least number of electrons in the M shell? Options are K, B, Mn, C, nickel, and D is scandium. That is potassium, manganese, nickel, and scandium. So which of the following element has the least number of electrons in its M shell? So the element that has the least number of electrons in its M shell is K. So K is the element that has the least number of electrons in its M shell. Explanation. As all we know that the atomic number of potassium is 19, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 2 to 4, 4, 10, 10 to 12, 12, 6, 18 or 19. So this is the electronic configuration of potassium. This is the electronic configuration of potassium. 3s2, 3p6. So 3s2, 3p6 is equal to M shell. So K has only 8 electrons in its M shell. 3s or 3p6. That means 6 plus 2, 8. So K has only 8 electrons in its M shell. So this is the right answer. Next is your question number 9. And your question number 9 is which of the following sets of the ions represent a collection of isoelectronic species? Atomic number F9, Cl17, Na11, Mg12, aluminium 13, potassium 19, calcium 20, and scandium 21. So which of the following sets of ions represents the collection of the isoelectronic species? Your question number 9 is which one of the following sets of the ions represents a collection of isoelectronic species? Atomic number fluorine 9, chlorine 17, sodium 11, magnesium 12, aluminium 13, potassium 19, calcium 20, and scandium 21. Options are K positive, Ca2 positive, Sc3 positive, and Cl negative. Second one is Na positive, Ca2 positive, Sc3 positive, F negative. Third, K positive, Cl negative, Mg2 positive, Sc3 positive. D, Na positive, Mg2 positive, Al3 positive, and Cl negative. So which one of the following sets of the ions represents a collection of the isoelectronic species? K positive, Ca2 positive, Sc3 positive, Cl negative. This is the following set of ions that represents a collection of the isoelectronic species. That is K positive, Ca2 positive, Sc3 positive, and Cl negative. Explanation जो है, isoelectronic species are those species which have the same number of electrons. Isoelectronic species are those species which have the same number of electrons. K positive, that means it has loses the electron, that is 19 minus 1 is equal to 18. Ca2 positive, that means it loses 2 electrons. So the atomic number of calcium is 20. 20 minus 2, that is to 18. Sc3 positive, that means it loses 3 electrons, and the atomic number of scandium is 21 minus 3 is equal to 18. Chlorine negative, that means it gains the electron, and the atomic number of chlorine is 17 plus 1 gain karega 8 and the 18. So this is the right set of the ions present in the collection of the isoelectronic species. Next is your question number 10, and your question number 10 is, in the ground state, an element has 13 elements in its M shell. The element is, options are copper, chromium, nickel, iron. In the ground state, an element has 13 electrons in its M shell. Then the element is either copper, chromium, nickel, and iron. That is the question number 10. Either that element is known as chromium. That element is known as chromium. So in the ground state, an element has 13 electrons in its M shell. The element is chromium. The element is chromium. M shell means its third shell. M shell means its third shell. Third shell. N is equal to 3. Number of electrons in N shell. Number of electrons in M shell is equal to 13. Number of electrons in M shell is equal to 13. As the electronic configuration is 3s2, 3p6, 3d5. This is the electronic configuration. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This is the electronic configuration of the chromium ion. Hence the element is chromium. The element is chromium. This is the right answer for the question number 10. Next is the question number 11. The electrons of the same orbitals can be distinguished by the electrons of the same orbitals can be distinguished by either principal quantum number, azimuthal quantum number, spin quantum number, and magnetic quantum number. The electrons of the same orbitals can be distinguished by either principal quantum number, azimuthal quantum number, spin quantum number, and magnetic quantum number. And it is your question number 11. So it is the spin quantum number. Spin quantum number. Spin quantum number. This is the right answer. Next is your question number 12, and your question number 12 is, consider the ground state of chromium atom Z is equal to 24, the number of electrons within the azimuthal quantum number L is equal to 1 and 2 respectively. L is equal to 1 and 2 respectively. So consider the ground state of the chromium atom, that is Z is equal to 24. Then the number of electrons in the azimuthal quantum number L is equal to 1 and 2 are respectively. Number 1 is 12 and 4, 12 and 5, 16 and 4, and 16 and 5. Options are 12 and 4, 12 and 5, 16 and 4, and 16 and 5. So it is your question number 12. This is your question number 12. So beta, that is 12 and 5. 12 and 5. 12 and 5. 24 chromium is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This is the electronic configuration of the chromium. As we know that P L is equal to 1 and DL is equal to 2. PL is equal to 1 and DL is equal to 2. So for L is equal to 1, total number of electrons is equal to 12, that is 2p6 and 3p6. 2p6 and 3p6. For L is equal to 2, total number of electrons is 5. Total number of electrons is 5. Total number of electrons is 5. So hence, electronic configuration, the ground state is 3d5. So this is the right answer for the question 12. That is the consider the ground state of chromium atom Z is equal to 24. Then the number of electrons within the azimuthal quantum number L is equal to 1 and L is equal to 2 respectively. Then the answer is 12 and 5. Next is your question number 13. And your question number 13 is a body mass of 10 milligram. A body mass of 10 milligram is moving with the velocity of 100 meter per second. The wavelength of de Broglie wave associated with it would be H Planck's constant, that is 6.63 into 10 raised to power 34 joule inverse. First question is 6.63 into 10 raised to power minus 37. B 6.63 into 10 raised to power minus 31. C 6.63 into 10 raised to power minus 34. And D is 6.63 into 10 raised to power minus 35 meter. And it is your question number 13. So the answer is 6.63 into 10 raised to power minus 31 meter. 6.63 into 10 raised to power minus 31. This is the right answer. Mass is equal to 10 milligram. 10 multiplied by 10 raised to power 6 kilogram. Then 100 meter per second. And as all we know that lambda is equal to h upon m nu. Lambda is equal to h upon m nu. H की वैल्यू हमें दी गई है 6.63 into 10 raised to power minus 34 divided by 10 into 10 raised to power 6 into 100. 6.63 into 10 raised to power minus 31 meter. This is the right answer, that is 6.63 into 10 raised to power minus 31. This is the right answer. Next is the question number 14. And your question number 14 is the ionization enthalpy of hydrogen atom is 1.312 into 10 raised to power, not determinable, but 106 joule mole inverse. The ionization enthalpy of hydrogen atom is 1.312 into 106 joule mole inverse. Then the energy required to excite the electrons in the atom from n is equal to 1 to n is equal to 2. And it is your question number 14. That is 8.51 into 105 joule mole inverse. Second one is 6.56 into 105 joule mole inverse. Third, 7.56 into 105 joule mole inverse. And the last one is 9.84 into 105 joule mole inverse. So this is the question number 14. And the right answer is 9.84 into 105 joule mole inverse. 9.84 into 10 raised to power 5, not 10 raised to power 5, but 105 joule mole inverse. The ionization enthalpy of the hydrogen atom is 1.312 into 106 joule mole inverse. Then the energy required to excite the electrons in the atom from n is equal to 1 and n is equal to 2 is 9.84 into 105 joule mole inverse. Next is your question number 15. And your question number 15 is, in hydrogen atom, energy of the first excited state is minus 3.4 electron volt. Then find out kinetic energy, same orbit of the hydrogen atom. Number one is 3.4 electron volt, second one 6.8 electron volt, C minus 13.6 electron volt, and D is 13.6 electron volt. So in hydrogen atom, energy of the first excited state is 3.4 electron volt. Then find out the kinetic energy of the same orbit. Options are 3.4 electron volt, 6.8 electron volt, minus 13.6 electron volt, and last one is plus 13.6 electron volt. So the answer is 3.4 electron volt. So this is the right answer, that is 3.4 electron volt. So for hydrogen atom, kinetic energy is equal to the negative of the total energy, and the potential energy is equal to the twice of the total energy. The first excited state, or the first excited energy state orbital, that is minus 3.4 electron volt. The energy of the first excited state is minus 3. The energy of the first excited state is minus 3.4 electron volt. This is the energy of the first excited state. Then the kinetic energy of the same orbit. Then kinetic energy of the same orbital. Is equal to minus 3.4 electron volt is equal to minus 3.4 electron volt. Therefore, the kinetic energy of the same orbit of the hydrogen atom is 3.4 electron volt. So this is the right answer, that is 3.4 electron volt. Next is your question number 16. Which of the following sets of the quantum numbers represents the highest energy of the atom? Option 1 is n is equal to 3, l is equal to 0, m is equal to 0, s is equal to plus 1 upon 2. B, n is equal to 3, l is equal to 1, m is equal to 1, s is equal to plus 1 upon 2. Third, n is equal to 3, l is equal to 2, m is equal to 1, s is equal to plus 1 upon 2. D, n is equal to 4, l is equal to 0, m is equal to 0, s is equal to plus 1 upon 2. So which of the following sets of the quantum numbers represents the highest energy of the atom? So n is equal to 3, l is equal to 2, m is equal to 1. N is equal to 3, l is equal to 2, m is equal to 1, and n is equal to 3, l is equal to 2, m is equal to 1, s is equal to plus 1 upon 2. So this is the following set of the quantum numbers that represent the highest energy of the atom. Because n is equal to 3, l is equal to 0, represents the 3s orbital, n is equal to 3 and l is equal to 1, represents the 3p orbitals, and n is equal to 3, l is equal to 2, represents the 3d orbitals, and then n is equal to 4, l is equal to 0, represents the 4s orbitals. So the order of the increasing energy of the orbitals is 3s less than 3p, less than 4s, less than 3d. So it is your question number 16. Now shift to the question number 17, and your question number 17 is, in the Bohr's model of an atom, the ratio of the kinetic energy of the total energy, the ratio of the kinetic energy to the total energy of the electron is quantum state n is, option 1 is A is 1, B is equal to 2, C minus 1, and D is minus 2. In the Bohr's model of the hydrogen atom, the ratio of the kinetic energy to the total energy of the electrons in a quantum state n is, options are 1, 2, minus 1, and minus 2. And it is the question number 17. So the right answer is -1. Option C is the right answer. So as we know that Bohr's model of the kinetic energy of an electron in its orbit is plus 1 upon 2 e square divided by r n bracket close. So total energy of the electron in an orbit e square upon 2r n. Therefore, kinetic energy divided by Te is equal to -1. Next is your question number 18. Which of the following statements does not form a part of the Bohr's model of the hydrogen atom? Options are: energy of the electron in the orbit is quantized. B. The electron in the orbit nearest the nucleus has the lowest energy. C. Electrons revolve in different orbits around the nucleus. And D is the position and velocity of the electrons in the orbits cannot be determined simultaneously. And it is your question number 18. So out of these statements, and the statement that does not form a part of the Bohr's model of a hydrogen atom is the position and velocity of the electrons in the orbits cannot be determined simultaneously. So this is the statement that does not form a part of the Bohr's model of a hydrogen atom, and the statement is the position and velocity of the electrons in the orbit cannot be determined by simultaneously. So this is the right answer. So this is the right answer for the question number 18. Now shift to the question number 19. And your question number 19 is, which of the following statements in relation to the hydrogen atom is correct? Option A is 3s orbital is lower in energy than 3p orbital. B. 3p orbital is lower in energy than 3d orbital. C. 3s and 3p orbitals are of lower energy than 3d orbitals. D. 3s, 3p and 3d orbitals will have the same energy, all have the same energy. So which of the following statement in relation to the hydrogen atom is correct? Is correct regarding the question number 19. So out of these statements in relation to the hydrogen atom is correct as 3s, 3p and 3d orbitals all have the same energy, all have the same energy, all have the same energy. And it is your question number 19. Because a hydrogen atom has 1s1 configuration, and its 3p 3d orbitals will have the same energy with respect to 1s orbital. So this is the right answer, that is 3s, 3p and 3d orbitals will have the same energy. Now it is our last question for our today's live video lecture, that is a subshell with n is equal to 6, l is equal to 2 can be accommodate a maximum 12 electrons, 36 electrons, 10 electrons and 72 electrons. A subshell with n is equal to 6, l is equal to 2 can accommodate a maximum of 12 electrons, 36 electrons, 10 electrons and 72 electrons. So it can accommodate a maximum of 10 electrons. Maximum of 10 electrons. Because n is equal to 6, l is equal to 2 means 6d will have 5 orbitals. Will have 5 orbitals. Therefore, maximum 10 electrons can accommodate. Therefore, maximum 10 electrons can accommodate to each orbital can have maximum of 2 electrons. So it can accommodate maximum of 10 electrons and each orbital can have maximum of 2 electrons. So this is the right answer for the question number 20. So here this is all about the chapter, that is the structure of atom, and Regarding this chapter, today we have discussed important 20 MCQ questions or objective questions from this chapter. So lastly, good night to all the students who joined with us our live APS classes.